रोहित।
यस मैम।
डॉक्टर अंकुश शर्मा को ऐड करिए को होस्ट में।
अंकुर सर। ओके ओके।
जय श्री राम सर।
हाँ, जय श्री राम। सॉरी यार, एक्चुअली क्या है, सिस्टम थोड़ा सा मैंने दूसरा ले लिया था,
अच्छा।
तो थोड़ी सी दिक्कत जा रही थी, फिर मैंने एनीवे
आपका आपका इस बैकड्रॉप पे हमें लगता है कॉपीराइट कर दिया उन्नत पंडित जी ने।
है।
ये जो बैकड्रॉप आप लगाते हो ना, इतना प्यारा लगता है ये कि मैं क्या बताऊं आपको।
अच्छा।
एक तो ईश्वर की कृपा से इतना अच्छा व्यक्तित्व ईश्वर ने आपको दिया, इतनी अच्छी छवि दी है, और पीछे आप
हाँ,
बैकड्रॉप और लगा देते हो तो मुझे वो मुहावरा याद आ जाता है, सीएम मुख सुंदर चंद्र समाना।
हाँ, 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 हाँ। क्या बात है।
बहुत बहुत
बहुत
धन्यवाद
बढ़िया।
सर।
चलिए, बहुत बहुत धन्यवाद आप लोगों का। और ये तो मेरा सौभाग्य रहता है कि आप लोगों के इस तरह के प्रोग्राम में जो है मैं अपनी शिरकत देता हूँ। और
गुड इवनिंग सर।
गुड इवनिंग, गुड इवनिंग। प्रगति कैसी हो?
सर मैं ठीक हूँ। और अंकुर जी ने बिल्कुल ठीक बोला है, योर पर्सनालिटी इज सूटिंग योर बैकड्रॉप।
अच्छा अच्छा, चलिए। सो नाइस ऑफ यू, थैंक यू वेरी मच।
जी जी सर।
मुझे डर ही लग रहा था, मैंने कहा कि कहीं प्रगति का फोन पहले अगर आ गया और मैं ज्वाइन नहीं कर पाया और वही हुआ, तो थोड़ा सा सिस्टम सिस्टम का वो था।
जी जी।
एनीवे, समहाउ मैंने ज्यादा टाइम समय नहीं लिया।
नहीं नहीं सर, यू आर ऑन टाइम।
हाँ, तो बट थोड़ा सा क्या होता है कि चीजें जो रहती है ना,
जी जी
वो कभी कभी वो हो जाती हैं।
जी।
तो आज बड़ा बिजी शेड्यूल भी था मेरा एक्चुअली।
अच्छा सर।
हाँ, थोड़ा सा। और फिर मुझे दो ऑप्शन थे, या तो मैं ऑफिस से ज्वाइन करूं, तो फिर वो ड्राइव, एक्चुअली हमारा ऑफिस बहुत दूर है ना, ये इंस्टीट्यूट 40 किलोमीटर दूर है।
जी जी जी
तो ये मैंने कहा ये लंबा खींचेगा आपका, 7 साढ़े 7 बज जाएंगे, तो फिर ड्राइवर किनकिनाएगा, 1 घंटा मुझे आने में लगेंगे, तो फिर वापस पहुंचेगा वो 9:30 10 बजे तक।
जी जी
तो
सर।
फिर मुझे घर भी पहुंचना था जल्दी से, तो एक्चुअली ऑफिस तो 6 बजे से पहले तो मैं निकलता ही नहीं हूँ।
जी सर।
तो आपके लेक्चर में यही मुझे टेंशन रहती है बस।
जी सर। सर स्टार्ट
चलिए।
करें या 5 मिनट वेट कर
हाँ,
लें?
जैसी आपकी इच्छा। अब तो हम ज्वाइन कर चुके हैं। अगर
ठीक है
आपको
सर
लगता
स्टार्ट।
है 5 1 मिनट और देखना है तो देख लो। कितने लोगों ने ज्वाइन कर लिया?
सर 100+ हो गए हैं स्टूडेंट्स।
ओह, ग्रेट ग्रेट। बहुत बढ़िया।
जी। नंदिनी स्टार्ट करिए प्लीज।
ओके मैम। मैम मेरी आवाज आ रही है?
हाँ जी,
हम्म।
आवाज आ रही है
आ रही
आपकी।
है।
ओके ओके, एक्चुअली यहाँ पर पावर कट है तो यहाँ लाइट नहीं है
ओह।
बिल्कुल भी। हार्वेस्टिंग हो रही है ना यहाँ पर वीट की, तो देयर इज नो लाइट फ्रॉम मॉर्निंग।
ओह।
ओके सो गुड इवनिंग एवरीवन। I welcome you all to the another lecture of Krishi Navyug 2026, and I, Nandini Sharma, co-founder and director, feel truly honored to welcome you all once again. Today, we have with us a personality who beautifully reflects that true greatness lies in knowledge, experience, and humility together. So, it is my immense privilege to introduce our esteemed speaker for today, Dr. Anil Dikshit Sir, Joint Director ICR, Raipur. Sir holds his MSc and PhD from prestigious Indian Agriculture Research Institute, New Delhi, and brings with him more than 3 decades of rich experience in agriculture research, training, and leadership. With over 300 publications, numerous national and international recognitions, and remarkable contributions in weed management, precision agriculture, and farmer centric innovation, Sir has played a significant role in strengthening sustainable agriculture in our country. But beyond all these achievements, what truly stand out is Sir's simplicity, humility, and dedication towards sharing knowledge. Sir, it is not just your achievement that inspire us, it is the way you carry them with such humility that makes you truly exceptional. For all of us here, learning from you is not just an opportunity, it is a privilege that we deeply value. With great respect and gratitude, I invite now Dr. Anil Dikshit sir to kindly share his valuable insights with us today.
थैंक यू नंदिनी फॉर योर काइंड वर्ड्स, एंड Really, it's indeed a great pleasure for me also for joining such a important events whenever the AgriMeet Foundation or the Agriculture Valley Foundation, Research Foundation. So they have also started the good activity in relation to the capacity building and the knowledge sharing with the young students, researchers, policymaker, industry people. So it's a really fantastic kind of events. And this 3 month on that day also we were telling about that engaging the people for 3 months is a big task. And the credit goes to Dr. Pragati Shrivastava and her team, and of course the Dr. Ankur Sharma, who is the mentor and the founder of all sort of events. So let me share the screen. The topic which I have chosen today is about the. Now it is showing the slide, na?
Yes, sir.
Okay. So my topic is the next generation wheat science, which is the of course that I was in the Wheat Science Institute, and here also I am developing the kind of expertise to the younger scientists. Of course, we are dealing with the biotic stress management in the area where entomology, pathology, biotechnologists, they have joined in my school, and we are working together for developing a kind of single window system. If you look at the overall scenario for the plant protection, here also I will try to accommodate the overall scenario for the wheat science strategy with in relation to the climate smart agriculture. And on that day we were telling you about how the best we can have advances in the biotechnology, artificial intelligence. Of course, the precision farming is also of my area, where we have developed some of the patents also. And now the time is for the artificial intelligence. So in some of the slides, I will try to sum up how best we can have artificial intelligence and the digital agriculture technology, which is a demand for today. And of course, that such programs serve because this is a 3 months agriculture internship come training program, Krishi Navyuk 2026. So basically, such programs serve as a crucial bridge between the classroom knowledge and the field applications. So basically, the kind of speaker you have chosen, I am pretty sure that they are doing the best in their field applications, and that's what their knowledge has to be translated in the classroom study, what the hybrid mode is there. So their knowledge and expertise can be fruitful and useful to the younger generation and the persons who are involved for such kind of program. Having the exposure for the research methodology and the interdisciplinary approach. So such kind of internship program is very much required. So now we'll start the business of our topic. Do is covering. The video window was obstructing the some of the point. Anyway, now if you look at the economic losses due to weeds, because whenever I am dealing with the weed science study and all the plant protection scenario, in fact, that I was invited for the agriculture, this agronomy congress also. So there I delivered the lead lecture on the recent advances in the biotic stress management. So there also the people convinced whenever the such program is there, the weed is basically a major biotic stress. If you talk about the biotic stresses, so biotic stresses is the comprising of the living organism. Living organism, what are the living organisms are there, which are restricting the crop yield and the crop growth. The first one is the weeds, which is accounting around the 33% losses due to the presence of weeds in field crop. The second one is the insect, and third one is the diseases. Then minor biotic stresses are the presence of microorganism, nematodes, then stored grain pest. So these are the complete picture of the losses due to biotic stresses in the field crop. So here the different studies have been carried out. You look at the 3 points which I have noted here. The first one from Sahu Saraswat is telling that 2,000 crore. And the Varshan and Babu, they did some study. The study means we have when I was in Jabalpur, it was we used to have a All India coordinated research project on the weed management. So we had some 25 centers around the country, and there we used to have experiments on the crop weed competition. So purpose of crop weed competition is to have some weed free plots and weedy check. So weedy check means you will allow the weeds in the field crops in the abundance. You will not control the weeds. And in weed free, we will keep the weed free period up to 60 days without means not having any weeds, means zero weeds. So with those studies, we had comparison. Then based on those study, the recent study is the from the 18 states that Yogita et al. 2018. So she conducted the study from the ICRP data only. So that she has come out about the 1 lakh crore is the latest figure is losses due to weeds. So you can think of that how much losses is there due to presence of it. So this is a picture. I think in many forum you might have seen this kind of slides, that 37% losses due to weeds, then 29% due to insect, 22% disease, and others I told you that microorganism and the nematodes like that. If you look at the major problem in the weeds in the Indian agriculture scenario, so here you look at that in the cropland situation, the Phallus minor, because in the rice weed system in Haryana, Punjab, this is the belt, Western UP. These are the belts where the rice weed system is the prevalent. And here the Phallus minor was the major weed. And in 1993, there was a problem of, because the one molecule was there, isoprotron. This was the molecule which was controlling the Phallus minor very effectively. But by continuous use of the same system, rice weed system, the problem of resistance has developed. The resistance business is the same, where the dentist also used to tell to the patient that you keep on changing your toothpaste after 6 months. So here also we used to tell to the farmers also that you adopt the herbicide rotation. Herbicide rotation means don't use the same kind of molecules or the same herbicides for a longer period of time. If you're going to control the weeds effectively, you keep on changing the herbicides and you keep on rotating your crops also. That's why the in the management system, or if you talk about the ecological management of any kind of plant protection, if you talk about the IPM module also, so there we used to tell to the farmers that you adopt the crop rotation. So here the main purpose of adopting the crop rotation is the only one, that you keep on changing your weed flora, you keep on changing your pest dynamic scenario also. Because the crop rotation is the system, it is not only going to control your weeds, it may your manage all sort of biotic stresses, be it insect, disease, and the other microorganism. And the Acarina clover is also for the rice, and wild rice is also there. Wild rice is the wild relative of rice, and this wild rice problem is such a severe problem, but answer is there. In the later part of my presentation, I will tell you that how beautifully the IRI people has developed the non-transgenic rice Pusa Basmati, Dr. A.K. Singh and team, and they have come out with the Imazethapyr resistant rice variety. So you can use the Imazethapyr on that rice variety, and your wild rice and the other weeds will be controlled fully, and your rice will not be killed. It means your rice will not be having any phytotoxic effect. So likewise, Cyprus Cynodon Pyrethrinium is there. I'll go a little fast otherwise, because I have a long working association with the many group in the area of wheat science, then here also in the Biotic Stress Management Institute also. So total 33 years of experience has completed now. And we started the Parthenium Awareness Week also, and still it is going on every month, means August month of every year. We are celebrating this. Celebrating means sensitizing the people. It's not a kind of celebration. It's a kind of sensitization the people that the Parthenium is such a deadly weed. And now the Parthenium has entered to the crop field also. Now here I have grouped into the non-crop land, but many crops have been infested with the Parthenium because of the non-seriousness from the farmers and the persons who are involved in the farming business. Then again, Lantana, Micania, mimosa, these are some invasive weed which are prevalent in the Kaziranga and the other national park, and again the Chromolina and the Saccharum paragraphs. These are again weeds which are prevalent in those area. And the water bodies, the water hyacinth, Salvinia, Hydrilla, and the Alternanthera. These are the weeds which are prevalent in the water bodies. If you talk about the parasitic weeds and the perennial weeds, so here the Orobanki, which is a very problematic weed in the mustard and the other brinjal tobacco crop. Then Striga is also a problem. Cuscuta is also a problem. And Dendrophia is also a problem in the mango. So likewise, these are some of the parasitic weeds which are prevalent in the different crops. So now I was talking about the non-transgenic and transgenic technology, how best transgenic technology can contribute for all sort of your plant protection system. And here also we are identifying some genes. If in fact we have some work on the weed genomics, because weed is such a plant which is having some kind of hardiness if you compare with the crop. So if you can utilize the gene of a weed, or if you can insert the gene of a weed to the crop cultivar, then certainly the plant which will be developed through the weed gene, certainly that will be the hardy, and that will strive hard in different climatic aberrant weather condition. So such technology can do the wonder in our agriculture food system. Now coming to the what are the emerging challenges are there in weed management because of the adoption of the dwarf yielding variety and the hybrids. The problem of wheat is more as compared to the non-yielding varieties, and because of the high use of fertilizer and the irrigation. So certainly the high input agriculture is again aggravating the problem of weeds. Again, you have altered agronomy of crop and the monocropping and the fixed cropping system also shifting the weed flora. If you are going for the monocropping, then you will have a problem of grasses more as compared to the dicotyledons, means broadleaf weeds. Again, that shifting in the crops, it may lead to the problem of broadleaf weeds again. So likewise, that's what I was telling you, that you have to based on the conservation agriculture system. And also management strategies, I will tell you later part, otherwise I will jump into the different kind of management system. Then there was, I was telling you about the Felis manner issue with the use of isoprotron. So development of herbicide resistance is also biggest issue. And not only the isoprotron Felis manner issue, here I tell you that we had an emergency registration for some 3-4 molecules which was substituted for the isoprotron. But again, the use of those herbicides also later developed the cross resistance, and after 2 to 3 years, we had a problem of again the herbicide resistant issue. Then herbicide residue hazards is also there. We had a problem of alachlor in the groundwater contamination in the soybean area, because the alachlor was the molecule which was very heavily using in the soybean crop, and Indore and the Malwa region is the famous for the soybean crop. But again, such studies carried out, and we had a working with the Monsanto group, but later on it was not found confirmation. So again, such kind of problem is there. So you have to be very critical and careful while using such herbicides in the such sensitive crops. Again, we are a lot of talking about the climate change and the other issues. So certainly we have to be very critical and careful while using any technology in relation to the climate change. But here, if you look at the problem of C3, C4 weed, here I'll tell you that due to climate change effect with the high carbon dioxide concentration and the changing in the temperature, the lot of studies have been carried out, and we have found that problem of C4 would be more. C4 weed means Parthenium, Ageratum, alternantha. This is more of C4 weed will be more, and again the efficacy of herbicides will be reduced or delay response will be there. If you are applying any herbicides for killing the weeds, the efficacy may go down. So here also we have to be very critical. Now, concerning about the stakeholder, what are their concern is there? The concern are more because of the invasion of new weed species, the rising cost of manual weeding because the labors are not available. So here the manual weeding, if the farmers are dependent on the manual weeding, it would be very difficult to control the weeds. Then non-availability of labor for weed control, that is also another issue because the labor availability is getting down and it's a very serious issue. Then application technique of herbicides is also very important aspects. Whenever I used to conduct the meeting with the farmers, so I have noticed that farmers, they are not able to tell you about what kind of nozzles have to be used for weed control, because the nozzles and the application technique is very different if you are using any kind of chemicals. The chemicals which are being used for insecticides and the fungicides, their application technique is not so serious as compared to the herbicides. Then non-availability of herbicides and the mechanical tools, that is also another issue. And another issue is the spurious chemical. Recently, we had an accident of some chemical in the soybean field near Hoshangabad, and our Honorable Agriculture Minister was very much serious about the issue. And I think he has taken some stringent action, and the government is also very serious about the action those who are involved for supplying the spurious chemical. And it must be, because the farmers, they are paying money, but they are not getting the quality material, quality inputs. So it is a very serious matter. And some of the herbicides are costly. So there that the stakeholders' concerns are there, and large packing of herbicides, it leads to the poor handling of the any chemical. Then registration of new molecules. The registration of new molecules, if you look at that, it requires 10 crores of rupees. Because the most of the chemicals, they are buying from the Chinese material, and those chemicals for the registration purpose is required, and they have to go for the different kind of bioefficacy study, toxicological studies. Because I was involved in the herbicide screening and the development of new molecules with the industry people. So I know that how much it is very difficult to have a registration of new molecules. Then again, the awareness extension and the concern of weeds of no man's land, when the Parthenium and the other weeds are there, which is the weed of means non-crop area. So when the weeds are there in the non-crop area, so nobody will take care of controlling those weeds, but it will spread to the field condition also. So it may damage your crop also in later part of your farming system. So coming to the future technological innovations, what are the technological innovations are there? So I told you about that, how best we can have advances in the biotechnology. And advances in the biotechnology is, of course, that CRISPR-Cas9 technique and the other stake genes business are there. Because in the my early age of working, I worked with the two stake genes. One was for responsible for the stem borer, means insect resistance, and another was for the herbicide resistance. That was for the glyphosate and the glufosinate. So such kind of studies the scientists have done. But again, the herbicide transgenic technology, the government is not putting forward for such kind of modern agriculture concepts are there, because of some NGOs are involved. They think that such technology may be harmful, or some negative aspects would be there. So we need to address these issues very seriously if the such kind of problem they are facing, because poor knowledge leads to the disaster. So here only point is that we have to tell to the academia or the industry stakeholders and the other people who are involved in such business, that how these technologies are the best suited for the farmers, and how best we can combat with all sort of problem. Then, of course, the nanotechnology, novel chemistry, the green chemistry business is there. I told you about the CRISPR and the omics and the myco and the bioherbicides are there. Of course, that bioherbicides we have developed at the some formulation level, and many companies, they have come out with the bioherbicides, but those are not so effective in the field condition. That is also another issue. So we have to again relook on those formulation, and we have to come out with the strong kind of formulation, so that will give the effective management technology, and it should be resilient and the sustainable agriculture with regard to the changing climate scenario. Then the microwave and the laser techniques are there, robotics, drones, artificial intelligence, and I'll tell you in the later part how best we can have a robotics and the drone application with the use of herbicides, because the drone applications is being allowed for some bisbaribate sodium, which is the herbicide for wheat management in rice crop. Then, of course, the intelligent agronomic practices, there are certain systems where we can have a precision agriculture and the sensor-based technology, whether it's a site-specific management or it's a micro irrigation and the site-specific fertilizer applications are there. We used to believe for the 4R business. 4R business, basically, if you look at if the fertilizer application is there or herbicide application is there. Why I'm telling you about the fertilizer? Because the government of India is going to launch a very mega program. It's just like a Viksit Krishi Sankalp Abhiyan. So again, now the all scientists of ICR, State Agriculture Universities and Krishi Vigyan Kendra and the State Department of Agriculture handling from the DAC. Now they are again going to the field. They will cover each and every district and they will tell to the farmers that how you can reduce the use of chemical fertilizer. Now you can use the other area of fertilization like green manure, composting, how best you can have all sort of intelligent agronomic practices which can reduce the use of chemical fertilizer. And that's what the government of India is planning to have a reduction in the chemical fertilizer, because the lot of subsidies going for the chemical fertilizations. Allelopathy, you know, the allelopathy is basically a chemical which is exudates from the roots or the stem and the leaf of one plant to another plant. So sometimes it is a synergistic and sometimes it's antagonistic. So any kind of antagonistic effect of one plant to another plant, one plant, if it is a wheat to crop, if it is a antagonistic, then it is going to have a, and many times it happened. That's why we have to control the weeds. But if the particular plant has the antagonistic over the wheat, certain varieties of rice we screened out in Chhattisgarh region, and we found that some of the rice variety of the farmer's point of view were very effective whenever they were growing together with the weed, and the population of weed was a little bit reduction was there. So that kind of detrimental effect of one crop to weed is called the allelopathy. And the problem of the allelopathy is that the many scientists, they have worked in the field condition and the lab condition, but the if you look at the formulation point, that formulation is not effective, and we have not come to that stage. So again, we have to precise the technology, and we have to relook on those kind of system. And now I tell you what are the conventional herbicides for weed control in rice there. So of course that butachlor, pitlachlor, pendimethalin, indofos, and 2,4-D, these were the herbicides which were using in the weed control in rice. And now the new low dose high potency molecules of weed control in rice have come, like bisbaribate sodium, phenoxaprop, xylophobutyl. Then the combination products are there, bensulfone and the pitlachlor and the chlorimuron and the metsulfuron ethyl. So these are some of the recommendations where the farmers can use those chemical, either post-emergence application or the pre-emergence application of the combination of bensulfuron and the pitlachlor. Again, in the wheat crop also, we have a lot of recommendation of the single molecule like clodinofop and the carbendazole. Again, the combination products were there, sulfosulfuron, metsulfuron, and the mesosulfuron and the idosulfuron for controlling all sort of your broadleaf weeds and the grasses. If you apply these chemical as a post-emergence, most of the post-emergence herbicides have to be applied in 2 to 4 leaf stage. And this 2 to 4 leaf stage comes at 25 to 30 days after sowing. So basically the key elements of the transformation, if you look at the conventional agriculture and the conservation agriculture. So ultimately the conventional agriculture is cultivating the land using the science and technology to dominate the nature. Basically, it's basically a highly resource consuming. And here the conservation agriculture is the least interference with the natural process. Means you can go for no tilling, you can reduce the tillage, you can have a biological tillage. And here in the conventional, you have a excessive mechanical tillage, and residual burning is not allowed in the conservation agriculture. That residue means you have to have a surface retention, and the mulching practices should be adopted in the conservation agriculture. But here in the conventional agriculture, residue burning and the incorporation practices there. And again, the here in the conventional agriculture, the green manuring has to be incorporated. In the conservation agriculture, the brown manuring is there. Means you can use the dhecha and grow for 45 days. And after 45 days, you have to kill with the use of 2,4-D. And that dhecha will be killed in a week. And that dryness and the burning of that dhecha is called the brown manuring. So again, I was talking to you about the how best we can have a climate change effect if you are going for the weed management program. So I told you that C4 weeds such as panicum and Digitaria amaranthus, these are some of the example of the C4 weeds. So they are likely to increase further, and because of the increased temperature favors the C4 weed over C3. And again, the Chenopodium album, which is a C4 and the broadleaf weeds, it can advance to 26 and 50 days of respectively of emergence and the flowering due to high temperature, increasing the temperature. And here you can see the herbicidal efficacy of under elevated CO2 and the temperature. And here the most of the chemical have shown the delayed response. Tembotrione is there. It's a herbicide for maize crop. Then isoprotron also delayed response, chlordinofop and tembotrione and the atrazine also. So these are some of the examples of the how the herbicide efficacy is also getting reduced by the changing climate scenario. And here the rainfall pattern and the drought also affecting the rice plant, which is unable to survive under the low soil moisture condition. And here also the amaranthus spinosus and the Lactochlora chinesis, they were not only able to survive but also produced a sizable number of branches and the tillers. So what I want to say here that because of the high rainfall, drought condition, or the changing temperature variation, the problem of C4 weed is more as compared to the C3 weed. So this is the nutshell, you can say. And the modern technology approach, I told you that marker-based assistant selection and the RNA approach for the biotic stress tolerance, then genome editing approach for insect resistance, and the metagenomic approaches are there. So these are the certain areas where we can have a these approaches can be used for the host plant resistance. And that's what in our institute also, and the biotic stress management area is all sort of scientists, if they are involved in the rice crop and the other crops of whether it's in CRRI Cuttack or IRI and the other institutions are there where they are involved in the DRR Hyderabad. So they have identified these such techniques, and with the marker assistant selection and the RNA approach, the host plant resistance method is they have adopted. And these are some of the examples of major herbicide tolerant crop system. Basically the two molecules they use to take into the study. One is the glyphosate and another one is the glufosinate. These both are the non-selective herbicides, and which can be, if you can spray these two molecules, glyphosate and the glufosinate, to the crop, the herbicide means the tolerant crop of canola, maize, soybean, and cotton, that crop will not be killed, but all the weeds will be killed. So this kind of herbicide tolerant system is there. So basically, it's basically inhibiting the EPSPS enzyme. This is the mode of action of the glyphosate, and the same is the enzyme inhibiting the ALS and the AHS enzyme. So ultimately, this sort of mode of action is there for controlling the weeds, and the your tolerant crop will not be killed. So this is the current status, how the ST crop is there in the Pusa Basmati. This was the, I was talking you that the IRI group, they have released the non-GM herbicide tolerant rice, Pusa Basmati 1979 and Pusa Basmati 1985, and the CR Dhan 807, which is tolerant to imazethapyr. And this imazethapyr is the herbicide which can kill your wild rice. And otherwise, there is no option of controlling the wild rice in the field condition. So basically, it is reflecting the India's preference for the non-GM options. Otherwise, the other options, another examples for the ST mustard is there, DMH11, which is tolerant to glufosinate and approved by the GAC. GAC is the highest body of genetic engineering approval committee of the DBT. But ultimately, this has was a split verdict and directed the creation of national GM policy in 2024. So again, this is in the litigation, and the same is the case for brinjal and the other crops also. So, the institutions which are involved in such kind of herbicide tolerant study, and they are making it through with their findings. But ultimately, the precautionary approaches balancing the ST crop potential with the environmental and the social concerns are there. So because of these issues, this 100% herbicide means GM technology, GMST crop is not being approved by the government of India. So otherwise, we should have been the GM herbicide tolerant mustard also, that is DMH11. And the farmers show the demand for the herbicide and technology, as the labor shortage and the high weeding costs make the ST crop attractive. So farmers growing cotton, rice, and soybean are especially keen on the ST options. So ultimately, the farmers are interested because the farmers, they are facing the problem of the labor shortage and other issues. But if you look at the opportunities and risk, the ST rice can boost the DSR by saving the water and labor. And ST mustard may cut the edible oil imports through the higher yields. That is true, because the government of India is importing lot of oil from the abroad, and if you go for such HT mustard technology and the other herbicide, means GM technology, certainly you may have a higher yield, and the problem of importing and the other issues may be reduced. And if you talk about the weed management study, then definitely the single herbicides may cause the resistant weeds and the environmental issues like drought, the drift, and the soil residue problem. So ultimately, this kind of ST technology will reduce the resistant issues and the other issues which are related to the environment. Then we may have an integration of the weed management with the ST crop that must avoid the pest global mistakes of the rapid herbicide resistance. And ST crops may be integrated with the integrated weed management. So using crop and the herbicide rotation, still seedbed technique. Still seedbed technique is basically in the pre-monsoon shower and the June, in the month of June, we used to irrigate the field, and we create the congenial condition to the weeds, that weeds allowed to germinate, and after germination we will kill those weeds by use of any non-selective herbicides like paraquat or the glyphosate, or we may have intercultural operation, or we may plow down those weeds into the field condition. So what the advantage with this still seedbed technique is that you will kill the first flush of heavy flush of weed seed in before sowing the crop. So that will give you the advantage in the later part of your crop season. So these are the some of the benefits is there if the herbicide tolerant crop is adopted by the farmers. So ultimately labor savings are there. Weeding cost may drop up to 4,000 to 6,000 per hectare. Likewise, different advantages are there. You can have a timely and broad spectrum control, reduce the crop injury, and you can have a support the conservation agriculture because it enables the zero tillage and the residue retention. Then smallholder flexibility means backpack spares is sufficient to control to apply the herbicides in the field condition. Then low soil residue of glyphosate and glufosinate, because the glyphosate and glufosinate has the minimal soil residue, because these are the chemical, as soon as it gets the touching with the particle of the soil, it's get the ineffective. So because it has to be applied at the post emergence. So ultimately these are the some of the advantage over the this thing. And if you talk about the risk and concern of the ST technology, so ultimately the some of the issues are herbicide resistance is there. Then gene flow is also there, that if the tolerance genes may spread to wild relatives or the conventional crop. So if that crop will not be killed by the use of glyphosate and the glyphosate. Why? Because that crop is also become the tolerant to the herbicide. So that will be called as a superweed. So that concern is also there. And if you look at the environmental impact, soil health, biodiversity, and water contamination concern is there. Then spread drift is concerned for fragmented farm. Then increased herbicide use is there. Resistance may require higher dose of multiple resistance herbicides. Then awareness gaps are there. Awareness gaps is the misuse of doses, timing, and the safety gear. These are all related to the herbicide application technique. Then socio-economic issues are there. Dependence on the seed farms and the unequal benefits. Then shared responsibilities there require the stewardship by all stakeholders. So ultimately, these are the some of the points which are showing the risk and concern to the farmer's point of view. What are the future prospect and the recommendations is there? So we have to expand the ST rice, develop the region specific and the basmati lines, then strengthen the mustard research, use the transparent communication to build the trust, then explore the ST soybean and the maize that also can be suitable for the central India and the mechanized farming. Then ensure the legal seed system that prevent the illegal and the poor quality seed material, because a lot of complaints are there from the farmers that they are getting the poor seed material, because whenever they are sowing the seed, if germination is not there, so ultimately that seed lot which they have purchased from the market or the any other sources, so their money has been involved, and if germination is not there, so poor farmer definitely will face a certain crisis as far as their livelihood and the other conditions, economic conditions are there. So promote the integrated weed management. This is very important because the IWM, IPM, and the such sort of integrated disease management. So it's a time and era of integration. So all sort of technology you have to integrate you can have a intelligent agronomic system where you can have a such sort of different integration of cultural, mechanical, and the chemical methods are there. Then farmers training is important. Then you have to use the Krishi Vigyan Kendra and the farmers producing organizations and digital platform for such training. And that's what the AgriMeet Foundation and the Agriculture Valley Research Foundations, they are doing the wonders for organizing such training program for faculty development, for the capacity building. So such programs are required, and that's what the ultimate the clients, they can get the benefit of such programs. And here the policy also has to clarify with the transparent regulation and the balancing innovation and the safety is concerned. So with this, the future prospect and the recommendations are there. These are some of the pictures of the how the zero-till wheat sowing after rice harvest using the Happy Seeders. Happy Seeder is the one of the important machine in the conservation agriculture program, that how best you can have a germination of crop, and how best you can minimize the disturbance of the crop residue without burning, because the burning is also again the major issue in the North India. This is the zero-till sown winter season crop, conventional tillage and the zero tillage. And this is the complete transformation of the conservation agriculture field. This is the picture from the Directorate of Wheat Research, Jabalpur, where we had a conservation consortia. And now that program is again running, and 12 years studies are there, that how you see that wheat sowing is there in rice residue. So you can manage the residue and you can minimize the tillage operation. So this is the beauty of the conservation agriculture. We also started the study of the conservation agriculture, means the role of conservation agriculture in the pest dynamic scenario. In what we have observed here, that you see the wheat under conservation agriculture in the 4 cropping cycle at IRA farm. And here the cotton in the right hand side is under conservation agriculture in the 4th cropping cycle. So you see that how best the field condition has been developed. Now after 6-7 years, the field will become the spongy, because the lot of residue material will be there in the soil, and again it will attract the lot of moisture, and your soil carbon will increase. So carbon sequestration, if you talk about the carbon footprint, so this is the best answer of adopting the conservation agriculture. This is the soybean. So coming to the basically the knowledge of wheat science, if you look at this picture, this slide will tell you that how best you can systematization of methods are there, considering the climate, soil, crop, weed infestation. So starting prevention is better than cure. It's my always the tell to the farmers that before you jump into the problem, it's better to have a prevention. So quarantine the any contaminated seed material, quarantine the contaminated any weed into the field. Then farm hygiene, well-rotten farmyard manure, compost, and cow dung. So you can have a clean crop seed and water implements. So because these are the area you can infest the field with the presence of weed. And of course that mechanical and manual methods are there, starting from the summer plowing. Summer plowing is also one of the best answer of controlling the many perennial weed in the field condition. Then of course the mowing, tillage, mulching, soil solution, burning, flooding, chaining, dredging, and the cultural ecological method is still seedbed, competitive resistant crop cultivar, sowing time method, spacing, irrigation, fertilization, intercropping. So these are some of the examples and the answer of tropical, cultural and the ecological method. Then cultural method, chemical method, it's herbicide mainly, and ultimately you have to judicious use of chemical. Whenever the problem of chemicals are there or the use of chemicals are there, whether it's a synthetic fertilizer or the any agrochemicals are there, you have to use very judiciously. And the use of chemicals should be the last resort. You can have a different options starting from the prevention. And of course, that biological methods are also getting importance, and use suitable bioagents are there, you can have it. So ultimately, the integrated weed management is the best answer to have a limiting weed density in the threshold level, and which is the have the answer for the environmental safety, increasing the yield, increasing the crop production, increasing the yield per capita. So ultimately, the other tools for the biotic stress, because I have compiled my lecture not only limiting to the weed only, but I try to sum up some of the biotic stress management tools also, so that you will get the full idea. And this lecture will cover entire biotic stress management scenario at the country level, at the field level, and how best you can modify your program whenever you are getting into the field, or if you are involved in the academics, so you can have a broader vision about the different tools of biotic stress management. So if again here also the preventive tools are there, that resistant tolerant varieties are there for different diseases, for insect, and again the seed material, seed treatment is the foremost important point. If you are having a soil-borne pathogen and the other related soil-borne biotic stresses. So healthy planting material is very important. And of course that crop rotation and soil solubilization, I told you that how best you can have a sowing time and spacing and the optimization. Then again, the cultural and mechanical field salutation trap, pheromone trap is also very important. And the NCIPM is also developed the pheromone trap, light traps in the field condition. And many farmers and the they are in the capacity building program, they used to teach to the farmers about the pheromone trap and the light trap. And again, the mechanical weeding is the hand picking is there, then balanced irrigation and the nutrition. It is always that balanced irrigation and the fertilization should be there. Then biological bioagents of Trichoderma pseudomonas is there. Then Trichogramma is there. Then biopesticide, neem, EPF. These are some of the points. And the farmers, they are using it, and many forum these bioagents are prevalent, Trichoderma and the Trichogramma. Then smart and advanced tools, IPM-based decision support system, then drone and remote sensing, ICT-based bets for forecasting, and the advisories are there. RNI and the CRISPR nano formulations are there. And of course, that chemical, that should be the last resort. And that is fungicide, insecticide, and the herbicides is there for chemical protection of in the soil and the crop. Now, I'll take some 10 minutes on the digital technology for weed management, because the digital technology is also very important whenever we are dealing with the weed management aspect. Because many forum we used to tell you about the AI applications, and AI applications and machine learning is basically are the reshaping in the weed management from a uniform input intensive practices into precision driven site specific system. So ultimately in the modern weed management technology, the AI and ML is a very good answer for the computer vision models for weed identification. So here the different drones, sensor, and image analysis software and the algorithms are there, which differentiating the grassy versus broadleaf weeds, detecting the herbicide resistant biotypes, and early stage of weed emergence detection. So these are the important issues related to the artificial intelligence and the sensor based technology. When we talk about the sensor, so basically sensors is the optical sensors are there, and the RGB and the multispectral cameras detect the differences in the color texture, and the NDVI based indices helps the identification of weed or the differentiating the vegetation from the soil. So ultimately, this captures the detailed spectrum signature, and the species level discriminations are there in the field conditions. So likewise, you can have a different kind of broadcast applications also with the use of drone. And here you see that how best the drone is involved for the pre-emergence application and the post-emergence applications technique. And recognition and the weed mapping, already I told you that how best you can have important for the site-specific weed management and the mid to late season weeds that are sparse. And generally the blanket applications are not advisable. So this is not required in the integration with the decision support system program. And ultimately, the in the precision weed control program, the variable rate technology and that is VRT. So ultimately, the artificial intelligence integrates the data stream. So it will have a sensor and the historical weather parameter to guide the interventions. And we have a smart sprayers also to detect the weeds in real time and the spray the micro doses. So ultimately, this technology can reduce the herbicide uses up to 70 to 90%. That is very much important. And you can have a environmental safety also. So this is the workflow that shaping file overload is there, and the detection models are there. And here the near real-time detection and the spraying is there. That weed emergence timing is based on the temperature, moisture, and the weed population dynamics there. Then risk of herbicide resistance develop. So this enables the proactive rather than the reactive management. So ultimately, you have to have a creation of perception maps and the real-time detection and the spraying technique for the real-time alerts and the integration with the mobile apps and the field level advisories. This is the weed detection approach, canopy reflection, the canopy lidar, etc., and the machine learning. I told you that the integration with edge AI for on-device and the real-time processing, and use of swarm robotics for large area weed control. That is also advisable and effective. This is the weed detection based on the machine learning. Already I told you that several parameters use the artificial neural network. This is the another national weed and crop emergency repository. Of course, it's from outside country, AGIR. So, but these certain models and the softwares is very effective, and the foreign countries, they are doing the wonders in this area. And of course, they Here also the scientists, they have also started working on this climate smart agriculture framework with the artificial intelligence, machine learning, and data analytics, which combined with advanced sensing technology for different kind of mapping and field level connections. So this crop image repository, with the help of these, are the organizations which they are doing it. PSA, that is a Precision Sustainable Agriculture, USDA, TEXA, NC State, Aarhus University, and the GROW. International Weed Recognition Consortium is also there. And the IWRC, the vision is to promote the development and use of digital imagery for advancing weed research and the precision weed control application. So these are the certain organizations which are involved in the digital agriculture, and they are doing the wonders. So ultimately, and here also the different kind of worker, they have been involved in the Canada, Korea, Brazil, and Australia. So this consortium is there, then same thing. This is the estimation of weed seed production is there, how best you can. This is herbicide injury evaluation, the 2,4-D injury and the ixolate dicamba. So already most of the points I have covered, and ultimately if you look at the conclusion of my talk is to have an integration of weed management involving the chemical and the non-chemical method, that is residue cover cross variety, is essential for the success of conservation agriculture system in the long run. And conservation agriculture is a machine, herbicide, and management driven. Three things are very important. That machine mostly the happy seeder and the super SMS, that is straw management system. And because mainly you have to manage the straw. That is the biggest hurdle. That's why the farmers, for the easy things, they are burning immediately the straw. But here, the best point is that with the use of machines, herbicides, and the management, you can manage those straw beautifully, and you can have a successful adoption also. So this technology of conservation agriculture has the immense potential, and ultimately this approach minimizes the chemical use and enhances the crop productivity, and it is sustainable for the environment. And ultimately the digital technology or the site-specific weed management technology or the artificial intelligence and the machine learning for detection. So this already depends on the needs, and it has to be aligned well with the next generation agriculture policies and the digital farming initiative. So in the last quote of Albert Einstein is there, that we cannot solve our problem with the same thinking we used when we created them. So with this note, thank you very much for patiently hearing my talk of new advances of next generation weed science, and of course the topic which has widely covered on the overall biotic stress management scenario in relation to the changing climate scenario, and what are the new technologies are there, and how best we can have those technology to integrate with the existing conventional system for best use of farmers' upliftment and the socio-economic conditions and best of our Indian agriculture. That is the important for innovations focused framework. Thank you very much.
Thank you so much, sir, for this valuable session. I think we all are inspired by you. So we are opening the chat box. If anyone is having any kind of query, you can directly type, or you can also unmute yourself and directly ask your questions.
वाकई में सर इतना सेल्फ एक्सप्लेनेटरी लेक्चर रहा, इवन शुरुआत से जब नंदिनी ने आपका इंट्रोडक्शन दिया उससे लेके अभी तक मैं इंटायर लेक्चर का पार्ट रहा, और इवन एक पेज पे मैंने अपनी कलम से कम 10 पॉइंट लिखे पीपीटी से। किसी भी पीपीटी में आपने कोई ऐसी गुंजाइश नहीं छोड़ी कि कोई व्यक्ति कोई क्वेश्चन कर सके, आपने वहीं उसको सॉल्व किया। इतना सेल्फ एक्सप्लेनेटरी अपने आप में। फिर भी चूंकि प्रोटोकॉल है कार्यक्रम का कि हम 10 मिनट डाउट क्लियरिंग सेशन, जिसको हम डीसीएस बोलते हैं, 10 मिनट का ओपन है। आप मर्यादित रहते हुए जो भी विषय वस्तु है, जो टॉपिक है आपके पीपीटी का, सर का जो एक्सपर्टीज है, सर के जो डोमेन है, उससे रिलेटेड आप 1 to 1 बात या तो चैट बॉक्स में कर सकते हैं, या आप अपने माइक को अनम्यूट, ये फ्रीडम आपको हमारे एडमिन महोदय देंगे कि आप अपने आप को अनम्यूट करके भी बात कर सकते हैं। तो 10 मिनट किसी को यदि साइंटिफिक डिस्कशन करना है इस पर्टिकुलर डोमेन और पर्टिकुलर टॉपिक पे, तो हम उनका स्वागत करते हैं। प्लीज।
We have got a question to discuss about nanotechnology.
Nanotechnology is the basically use of nanoparticles. Nanoparticles means very minute quantity of any chemical, and with that use of that minute quantity of any chemical with the formulation, and the nanotechnology requires the little quantity of that particular molecule for the use of controlling weeds or any pest in the field condition. And basically the nanotechnology also comes under the green chemistry program, which is environmentally friendly and which has the no residual toxicity in the field conditions.
Next, weed management systems so that food nutritional value is severely increased naturally.
No, I could not get what? Weed management?
Apurv, actually, could you please write your question again? Is there any weed management system which will naturally increase the food nutritional value?
No, without controlling the weeds, you cannot have a natural control of weed management. My point is here that if you take the example of organic agriculture and the natural farming, so what we say here that in the organic agriculture we used to have a outside material of input of organic sources in the organic agriculture, but in the natural farming, the whatever the suppose cow is there, and with the help of cow urine and the other material, you have to manage, and ultimately that the what says in the natural farming is basically the use of your residue mulching. So ultimately, that is the biggest strand, and with the help of residue and this thing, you can control the weeds naturally in the field condition without the involvement of any chemical. And other things are also there. Other things means you can have a changing in the sowing time. You can have a closer row spacing. So the summer plowing, if you have listened my lecture, so all sort of things I used to incorporate so that you can have a broader thinking of those areas.
The next question is, sir, what are the ways or works which ICAR is doing so that government can approve HT crops, and on which new crop ICAR is working and how?
No, ICR is working. ICR is working on the basically non-GM crop because the working in the GM technology, the government approval is required, and now the government is on back foot because of the Supreme Court decision. Otherwise, the ST mustard was ready. It was almost going to be released in the public domain, but because of some non-government organizations and the other people, it was put into the litigation, and it was now withhold the decision. So that is again the sensitive issues. So it is very difficult to say that uh, uh, how the government can approve it and this thing.
Livestock role in wheat management and sustainable agriculture.
Livestock?
Role of livestock in weed management and sustainable
Role of
agriculture.
livestock, I told you, in the natural farming, the use of cow urine and the use of the different Agni Shastra and these are the formulations are there. So that is because the cow dung is the biggest source of infestation of weeds. If raw cow dung is there, then definitely your field will be infested with the lot of weeds. So again, it's a cautionary that use of FYM should be well rotten. It should be a cold FYM. It should not be a hot FYM. Otherwise, your field will be full of infestation of weeds. And again, the quotation is also there: 1 year seeding and 7-year weeding. If your field has infested with one seed in 1 year, then you will have to strive hard to get the control of particular weeds for the 7 years. That much toughness is there for controlling the weeds.
The next question is it true that shelf life of organically grown vegetables is less than chemically controlled?
So I could not get it. What chemical control means?
Means the shelf life of organically grown vegetables is less than the vegetables which are being grown on chemicals like fertilizer, pesticides.
No, this he is telling that organically growing produce, the shelf life is less.
Yes.
No, I don't agree. Few days back only, I brought some mangoes. When I opened, the lower layer of mango was fully rotten, and it was giving me the bad smell because of some chemical ethylene was there in the pocket and this packet for ripening the fruits, and that material must be infested with the chemical. So it is not acceptable that organically growing compound has the shelf life is less as compared to the chemically grown. I don't agree.
The next query is, can you suggest a project for biotech engineer for weed management and which technique they can use?
You can use biotech engineering means you may have a robotics, you can have a laser technique, you can have a microwave technique, you can have a different kind of drone applications. So such sort of areas are there for managing the weeds in the field conditions. And even I tell you, the IIT Kanpur, they have developed the robotics for weed management in the field condition. And they have patent on it, and I don't know when they are going to commercialize it. Because ultimately the any patent does not have the commercial value, it is not going to serve the purpose in the larger interest. So that robotics may come soon in your field for giving the best weed management practices.
Everybody is appreciating you in the comment section, sir. And if
Thank you.
anyone is having any other query, you can also unmute yourself and you can directly ask a question.
If any student is having any sort of queries, you can unmute yourself and ask question to sir, or you can put your question in the chat box.
Shall we conclude, Pragati ma'am?
Yes, Nandini, I think you should conclude.
Okay, so thank you so much, sir, for such a wonderful and insightful session. Your words were not only informative, but also deeply inspiring. We truly appreciate the way you simplified complex concepts and shared your vast experiences with such clarity and humility. We feel genuinely grateful to have you with us today, and we are having the opportunity to learn from you today. Sessions like these don't just teach us, they leave a lasting impression on how we think and grow. So, once again, thank you so much, sir. Be connected with any future academic activities with us.
Thank you. Thank you very much to Dr. Pragati, Dr. Ankur Sharma, Dr. Nandini, all your team, Rohit. Thank you very much. And all the participants, more importantly, the participants, because they are the real strength for this training program. And I'm very happy the kind of interactions they had during the session. And this shows that how much they are active and eager to learn many things and updating their knowledge, capacity building. That's a great thing. And I hope that with a span of 3 months, they may be able to learn many things, and they will become the really hardcore scientists, and they may teach the many of the faculty members also. Thank you very much, and wish you all the very best.
Thank you so much, sir.
You all can leave. Thank you so much
Yeah.
for joining.